All right, if we're going to find out if these two functions are inverses of each other, we're going to first find f of g of x. We're going to see if that gives us an x back. And assuming it does, then we'll find g of f of x. See if that gives us an x back. If both do, then f and g are inverses of each other. Starting with f of g of x. The way we find f of g of x, we start with g of x because that's inside, right? G of x is defined as x squared plus 3 over 2. So over here I'd say this equals x squared plus 3 over 2, all plugged into the function f, right? Just replace what's inside the parentheses here with what g of x equals here. We now understand, as we figure out this part of the function, the x squared plus 3 over 2, we are plugging in the place of x in the function f as it's defined. So if we place this x up here, you have the square root of 2 times x becomes x squared plus 3 over 2, all of that minus 3. So a little bit of plugging in to start. We've now set up something we can simplify. So as we go through the steps to simplify, starting underneath the root, we got some distributing to do, right? If this is 2 over 1 and this is all over 2, those 2's would cancel, right? Leaving you with x squared plus 3. Of course, the root is applied to all of this, and you have a minus 3 at the end we got to tack on. So the x squared plus 3 here represents the distribution of that 2. Okay, from here, like terms of 3's cancel out. You are left with the square root of x squared. The square root of x squared, of course, would be x. We find that f of g of x equals x. So far, so good in showing that f and g are inverses of each other. We move over to g of f of x. Start on the inside, work your way out. We start with f of x. F of x is the square root of 2x minus 3. We are plugging that into our function g. As you plug into the function g, wherever we see an x, see the one up there, I replace that x with the square root of 2x minus 3 as a quantity squared, right, since all of that x is being squared, plus 3 all over 2. Everything has been plugged in. Time to simplify. I've got this radical that's being squared, meaning the radical cancels out. You've got 2x minus 3 plus 3 over 2. Collecting like terms in the numerator, the 3's cancel out, which means you have 2x over 2 left, at which point you can cancel the 2's out, meaning everything would equal x. And we're trying to determine if the functions are inverses of each other. Well, it appears that yes, they are inverses of each other. All right, so 2 new functions defined. I'm going to show that they're inverses of each other. First, we're going to look at f of g of x, see if that gives us x. Then we're going to look at g of f of x and see if that gives us x. Starting with f of g of x, working from the inside out. G of x. G of x is defined as 2x cubed minus 1. So 2x cubed minus 1, that's what we're going to plug into our function for f. We take that 2x cubed minus 1, plugging into our function for f wherever we see an x. We see that 1x up here. So we replace that x. And as we replace that x, we would have the cube root of 2x cubed minus 1, replacing the x, plus 1 all over 2. as you simplify, you'll notice in the numerator the 1's cancel out. You've got the cube root of 2x cubed over 2, where now the 2's cancel out. Now you have the cube root of x cubed. Take the cube root of something cubed, you get that something back. So this would all equal x, meaning so far so good. For g of f of x, start with f of x. Working from the inside out, f of x is the cube root of x plus 1 all over 2. We are taking that, plugging into the function g. So as we plug that in the function g for every x that we see, when we substitute in, we've got 2 times x gets replaced with cube root of x plus 1 over 2. All of that is being cubed, right? Minus the 1. Everything has been plugged in, so we're ready to simplify, starting with the fact that I'm cubing a cube root, kind of like on the last one when I was squaring a square root. That root's going to disappear. So you have 2 multiplied to x plus 1 over 2, which would remain after I cube the cube root. And then you got that minus 1 hanging on the end. We're ready to multiply that 2 through. If we multiply the 2 through, this 2 is over 1, meaning these 2's would cancel. So all that would remain is x plus 1 minus that 1. And it looks like things are going to work out for us again as these 1's cancel out. G of f of x gives us x back. Are these functions inverses of each other? Whoops. Yes, they are.